Today we're going to cover Notes 3.3, which is solved by completing the square. So if you'll remember, we started Chapter 3 by introducing the complex number set. So we now know that there are numbers outside of the real numbers. They're imaginary. Then last week we went through and we found two methods of solving. One was called solve by taking square roots. If you have only one x in the whole equation, solve by taking square roots is an excellent plan. We love to do that. The other was solve by factoring. So if you don't have just one x in the equation, you've got like an x squared and an x. You can't solve by taking square roots because they're not like terms. So we did solve by factoring. Well, we're going to start to run into some things that look like trinomials that have x squared and x, but they don't factor. And so that would normally be a roadblock for us, but we're going to say there are some other solving methods we can use. One of them is completing the square. And so we'll do completing the square today. We'll do quadratic formula tomorrow. And those will be our last two solving methods. We'll add to our foldable on Wednesday, and then you guys will quiz on Thursday. So our main goal for the week is to continue solving quadratic equations. I will say this before we get started. Completing the square is probably, not that it's my least favorite, but it's probably the least likely I am to use it in terms of solving a quadratic. I would solve by factoring or quadratic formula more often than I would solve by completing the square. But it's important that we cover completing the square because that's where the quadratic formula comes from. So when we get the quadratic formula tomorrow, which some of you guys already know, it is completing the square in one formula. Okay, so that's at least worth mentioning. We'll cover it, we'll use it, but we're more concerned with probably some of our other solving methods, or those will become our go-to methods, the factoring and the quadratic formula. So jot this down in your notes. What we were talking about on that very first slide, where we were factoring the trinomials, and then Sierra noticed that she could write them as a binomial squared. Those were called perfect square trinomials. And a perfect square trinomial is any trinomial where the two factors that multiply to make the trinomial are the same. Perfect square trinomials. Two factors that multiply to make the trinomial are the same. It's basically the same definition as a perfect square number. Why is 25 a perfect square? Because we can have two factors, 5 times 5, that are the same. Same for 36, 6 times 6. So here we're saying it's not just a number, it's got x's as well. Okay, it's got an x squared term, it's got an x term, and it's got a number term. But when you factor it, you get the same two factors. So below this definition, I have the same trinomials that we looked at the very first slide. And I kind of color-coded some things. So I took out our factoring piece and I put in Sierra's binomial squared. The x plus 6 squared, the x minus 5 squared, the x plus 2 squared, and the x minus 3 squared. And I added some colors there. So can you find any patterns between the blue, the green, or the red numbers? If you can't find any patterns, what are they? Jackson, you've got a pattern?
The green are perfect squares.
Okay, the green numbers are always perfect squares. Okay, so you're looking at 36, 25, 4, and 9. Excellent. I would always agree with that. If it is a perfect square trinomial, we should have perfect squares there.
All of them are divisible by the same number.
What do you mean by that?
For instance, the first one is they're all divisible by 6.
Oh, okay, so like the blue, the green, and the red number are all divisible by, they have some greatest common factor. And the greatest common factor is 6 for the first trinomial. What's the greatest common factor for the next one? 5, then 2, then 3. It's always that number over on the right side in the red. That's always the number that's the greatest common factor, so that's interesting. else do you notice? Maybe pick one equation at a time. So put your focus on one equation, maybe like x squared plus 12x plus 36 equals x plus 6 squared. What connections can you make there?
The blues are always double the reds.
Oh, the blues are always 2 times the red number. And that means that the red number is always half of the blue term. Do you agree with that? Half of 12, half of negative 10, half of 4, half of negative 6. Okay, so I'm going to write that down. This is always half of the middle term. And that's the blue number. What else? Think back to Jackson's comment about the fact that the greens are always perfect squares. How did those perfect squares relate to the other numbers in your equation? How do you get 36 as a perfect square? 6 times 6. Where do you see 6? At the end in the red. How do you get 25 as a perfect square? 5 times 5. Where do you see 5? At the end. Does that work for all the other ones? Yeah. So not only is this number half of the middle term, it's also the square root of the last term. So that's an important pattern as well. But I could pick either term. I could pick the blue term and just take half of it, and I'll know what goes in that group of parentheses. I could also take that last term and square root it, and it's the same number that goes in parentheses. Note that in terms of the sign in parentheses, whether it's going to be a plus or a minus, goes back to your middle term that's blue. So when it's plus 12x, I have plus 6 inside. When it's minus 10x, I have minus 5 inside. So that's important that you kind of pay attention to the sign. But that's a pattern that will be true for all perfect square trinomials, and that's going to build this. On the next slide, we're going to do a very small skill. It's called completing the square. We're not actually solving anything yet, but completing the square is a small tool that mathematicians use in a bigger problem. So the next slide, we're going to do the step of finding the number that completes the square. So you'll have a couple homework problems today, right at the very beginning, where this is all you have to do. I would definitely make sure I'm putting some examples in my notes today. For completing the square, it would be very helpful to have nice, clear notes to go back and look at and kind of figure out what you were doing for the different problems. So the book will say something, find the value of C that creates a perfect square trinomial, or find the value of C that completes the square. And after you find the value of C, then write it as the square of a binomial. So you have to do 2 things on these problems. You have to figure out what C is, and then you have to write it as a group of parentheses squared. So we'll look at that very first example, the x squared plus 8x plus C. Any brave souls out there that think they might know the number that completes the square of this trinomial, and then you can explain how you got it? Jackson? 16. Why do you say that C is equal to 16?
Because 4 plus 4 is 8. 4 plus 4 is 16.
Oh, okay. Did you hear his explanation? 4 plus 4 is 8. So that's like half of 8. And then 4 times 4 is 16. So that's the square root of 16 is 4. And so 16 must be the number that completes the square. I agree. Okay. So what does your group of parentheses look like inside? X plus 4. The number that's inside of the parentheses will be half of your middle term, so half of 8, and it will be the square root of the last term, which you determined was going to be 16. So x plus 4 squared. And that kind of goes along with what he said, x plus 4 times x plus 4. The 4's will add for outsides and insides to give us 8x, and then the 4's will multiply on the last term to give us 16. So using Jackson's same method, what's the number that completes the square for x squared minus 16x plus c? How would you find the number here? Damon?
Would it be 64?
C is 64. Excellent. Can you tell us how you got C is 64?
16 divided by 2 is 8. 8 squared is 64.
I think that's excellent. Just say, what's half of the middle term? So half of 16 is 8. And then square it. 8 times 8 is 64. So 64 completes the square. And his group of parentheses will look like x minus 8, right? So your middle term has a negative right there. That's going to carry over into your group of parentheses. It's going to be an x minus 8 squared. So that the number inside the group of parentheses is half of the middle term. Half of negative 16 is negative 8. And then the square root of the last term, the square root of 64 is 8. Okay. I'm going to give you just a quick minute or two to come up with your answers to the last two. And I'll walk around the room, kind of see how you're doing and answer questions if you have one for me. But then I'll come up to the front and I'll just put the answers on the board and you'll be able to check if you've got this down or not. So give this a go. We've got x squared minus 2x plus c. And then x squared plus 22x plus c. So see if you can do those same two things. Find the number that completes the square and then write it as the square of a binomial.
So on the first one, or on the second one, and can you also do those parentheses? Okay. How do you get that number? Think about how you got there.
Okay, I'm going to go over the ones on the board just really quickly. And this first one is worth mentioning a couple of things about really quickly. Think about what Damon said for the second problem, x squared minus 16x plus c. He said that to get the number 64, he takes half of the middle term, and then he squares it. So what's half of negative 2? Just negative 1. So we're going to take half of negative 2. So we're going to divide it by 2. We're going to get negative 1, and then we're going to square it. So what's negative 1 times negative 1? 1. I saw a lot of 2's as I was walking around the room, which is a pretty common mistake to think that 1 times 1 will be 2. But we've got to be careful with that, right? It's 1. Okay. So the value of c that completes the square is c equals 1, and then the parentheses is x minus 1 squared. Most people were able to get the binomial on that one right. We're having difficulty with the c squared, the 1 squared c's. So negative 1 squared is actually just 1. And then you can use that same method for x squared plus 22x plus c. Take half of the middle term, so that would be 22 divided by 2, and square it. That would be 11 squared, which is 121. So the value of c that completes the square is 121, and the binomial is x plus 11 squared. You'll have an opportunity to practice a couple problems like that on your homework. If you're having difficulties with that, raise your hand and see me at the very end of class when we have a little bit of work time, because that's like the basic skill you need to go to the next problem. And so if you're having trouble completing the square, that's going to pose a big problem for solve by completing the square. Okay. So that's a really small skill, and now I'm going to do that thing that everybody hates in math. I'm going to take your small skill and I'm going to put it into a big problem, right? So there's a lot more stuff that you have to do, but we're going to utilize this skill of completing the square. So again, I think it goes a long, long way to have nice examples in your notes for this completing of the square. That way you can go back to it, you can look, you can read, you can see how we did different things. On the right side of this, I'll uncover some steps that you can copy into your notes for this first example. And these would be the same steps you follow each time you solve a problem by completing the square. So now we're not just going to find the number that completes the square and rewrite it. We're going to use that as a tool to solve an entire equation. And to give you a little bit of background here, if I had x squared minus 8x plus 5 last week, I would look at that equation and I'd say, well, I can't solve by taking square roots because I have too many x's. I've got an x squared and an x. So then I should try to solve by factoring. But this has a coefficient of 1 and the last term is 5. Do you have factors of 5 that will add to make 8? No. So this one doesn't factor. We have to have some other method for solving when things won't factor. And that's where solve by completing the square comes in. So this is step number 1. I'll let you jot this down in your notes. Step number 1 says, first of all, just move the constant to the other side. The bullet points are just like extra reminders about this. Your goal by doing step 1 is to get x squared and x on one side alone. So you're isolating the x squared and the x term. I recommend leaving a little bit of space after the x squared and the x, because that's where you're going to complete the square. So leave some space there. So leave space to complete the square. So we want to move the constant from x squared minus 8x plus 5 equals 0 to the other side. And the constant term that's on the same side with x squared and x is this plus 5. So we're going to move it to the other side by subtracting 5. And I'm going to have x squared minus 8x. Remember, I'm going to leave a little bit of space where I'm going to complete the square, because this is the beginning of my trinomial. And so I'm just going to put equals negative 5 over here. I've got a little bit of space where I can complete the square. Is everybody okay with what we've done so far? Okay, step 2. Complete the square. So this is using your tool that we just went over on the last slide. Think about Damon's method. Take half of the middle term and square it. You're going to find that number that completes the middle term, or completes the square. And I added an extra bullet point. You got to remember to add this to both sides. So jot that down. Add to both sides. So complete the square. You're going to take half of the middle term and square it. And And then also make sure you add it to both sides. That's the place where a lot of people can make small errors. So what's the number that completes the square here? We already did this one, right? X squared minus 8x, take half of 8, that's 4. 4 squared is 16. So the number that completes the square is 16. And I'm actually going to put that on the left side. I like to circle it only for emphasis. There, I just added 16 on the left. But think about this in algebra. Go back to like your golden rule of algebra. What you do to one side of your equation, you have to do to the other side of the equation. So since I have that big plus 16, what do I have to do to the other side? Also add 16, right? So I have changed the balance of my equation by putting in a 16 that wasn't there originally. So in order to keep the balance, I'm required to add it on both sides of the equation. And so add 16 on both sides. Okay. That's a place where a lot of people will forget to do something. So they might just leave that other side as negative 5. Okay. Step 3 is rewrite your trinomial now. You just made it a perfect square trinomial, x squared minus 8x plus 16. And that can be written as the square of a binomial in a group of parentheses. So this is the whole reason that you're doing this process, is to do step 3, which is rewrite it. Okay. So I'm focused over here on the left side of the equation. This x squared minus 8x plus 16, I'm going to rewrite as the square of the binomial, which we were just practicing on the last slide. This would be x minus 4. I keep the sign of the middle term. It's negative 8, so it's going to be minus. And then the number that goes inside has to be half of the middle term and the square root of the last term. So half of 8 and the square root of 16 is 4. And do your work on the other side. Negative 5 plus 16 is 11. Okay. And you've just totally changed the game here. Instead of having an equation that has an x squared and an x, which last week needed to be factored, now we have an equation where when I look at the whole equation, I have only one x term in the whole equation. So when you see only one x term in the whole equation, you can solve by taking square roots. So that would be step 4. You are now free to solve, because all you have to do is take the square root of both sides and you kind of release x from that group of parentheses. And so you'll solve by taking square roots. Of course, when you're solving by taking square roots, you cannot forget the plus or minus, or you'll be leaving off an answer. And you must use reverse order of operations. So you have to undo the exponent first and then undo the addition and subtraction inside the parentheses. So where we're at, we have this quantity x minus 4 squared, and it equals 11. We're going to take the square root of both sides. A square root will cancel out the square so that I'm just left with x minus 4. Don't forget my plus or minus. And can I simplify the square root of 11? No, if you think about a factor tree, it's a prime number. It only has factors of 1 and 11, so there will be no doubles. It will not simplify. So I'll leave it as the square root of 11. And then continue to use my reverse PEMDAS. I'll add 4 to both sides. Remember that when we add 4, we'll put it in front of the plus or minus. Okay, just like we had done last week. So x equals 4 plus or minus the square root of 11. questions about what I did on a certain step or where a number came from? I have two more examples that we're going to work through, and I'll go a little bit quicker as we go through those examples. You'll notice that on the right side of the screen, I'll have shortened the steps. So now I'm just kind of thinking about the things that pop into my head, and I shorten it each time. As you practice with solve by completing the square, you should be shortening those steps in your own mind. Okay, what do I do next? And kind of giving yourself some, like talking yourself through the problem, what happens next. And we'll also look at some different types of solutions that we'll get. But this solution, you have two answers, and they're both irrational. 4 plus the square root of 11 and 4 minus the square root of 11. I could get them as decimals if needed, but otherwise we're just happy to leave it alone as 4 plus or minus the square root of 11. Okay. So let's look at our next example, which is x squared minus 6x minus 40. And like I said, I think putting an extra example in your notes is a good thing, because then you have another problem to look at, and you can compare. What did I do on that one? What did I do on this one? How do I do it on my homework assignment? So x squared minus 6x minus 40. Now you probably don't have to write the steps off to the side. These are just my shortened steps. So we're following the same steps as we were before. We're going to move the constant to the other side, and we're going to leave space to complete the square. So I've got to move the 40. I'm going to add 40 to both sides. I'm going to get x squared minus 6x, leave some space, equals a positive 40. I left that space so that I could do step 2, which is complete the square. And I should know the little pattern for completing the square. We'll call it Damon's rule for now. Take half of the middle term and square it. Okay, that works perfect every time. So I'm going to take half of 6, which is 3, and then square it. So the number that completes the square is 9. And I always have to remember to add it to both sides. The only reason I'm circling that plus 9 is to make it stand out, right? It doesn't mean anything mathematically. I'm just saying, oh, I added 9 on the left. Now I got to add 9 on the right. That's the number that completes the square. After you complete the square, you can rewrite your trinomial. So the whole reason that you did that was so these have the same factors of x minus 3 times x minus 3. So it will be x minus 3 squared. And on this side, 40 plus 9 will be 49. And once you've rewritten it, you have now set it up so that we can solve by taking square roots. And we don't want to forget our plus or minus. So we're going to take the square root of both sides. The square root will cancel out the square, so I'll just have x minus 3. And what do you know about the square root of 49? It's just 7, right? So no more square root. We're going to get rid of the radical. It's going to be plus or minus 7. Okay. And then I continue to solve by square roots. By using reverse PEMDAS, I'm going to add the 3 to both sides. And we get x equals 3 plus or minus 7. And what did we say we would do if we have like both regular numbers? Jackson? You actually have 2 separate x answers that could be nicer numbers, right? So you're actually going to do the plus and the minus here because they're like terms. They're just integer numbers. So we could say that x is equal to, what's 3 plus 7? 10. And what's 3 minus 7? Negative 4. So you have 2 nice answers for x, and we kind of talked about that the other day. You would prefer that I give you a nice number instead of a plus or minus solution, okay, if possible. Okay, when you get answers that come out nicely like this, like you could take the square root of 49 and the radicals totally disappear, this is a very interesting occurrence, and this is my very first meme ever, so enjoy it. I'm pretty impressed. What's that look for? This is my first meme I've ever made. You're not impressed? Well, there's Grumpy Cat. And Grumpy Cat is saying he solved by completing the square when he could have just factored it. So when you get these nice numbers, this means that your original trinomial was factorable. It can solve by factor or it can solve by completing the square. You'll get the same answers, but completing the square is probably more work. So if I were to have looked at this more carefully in the beginning, do I have factors of negative 40 that add to make negative 6? How about 10 times 4 if 10 is negative? So then I could have factored this out as x minus 10 and x plus 4. Would that give me my outside and inside terms to make negative 6? Yeah, it'd be negative 10x and positive 4x. And then negative 10 times 4 would be positive or negative 40. And then I could have just set these answers equal to, or these factors equal to 0, and my answer would have been 10 and negative 4. So I have a little bit of a grumpy look on my face when I realize I just did way more work than I really needed to do. The reason I show you that is so that you can kind of start to look with a more keen eye at your problems. You might check to see if they're factorable first, and then if you say, I can't factor it or I can't find the factors that work, then go to another method like completing the square or quadratic formula. But those methods will usually just require a little bit more time in completing them. So it's beneficial to you to check for factoring first. If factoring works, it'll probably be quicker. Okay? I'm sad that you're not impressed with my meme. How many of your other teachers make you memes? Exactly. We're going to do one more, and I'm going to kind of breeze through this one. I'm going to uncover my 4 steps, and I've really shortened them. So these are kind of the things that I tell myself in my head, like as I'm doing a problem. These are the different things that I got to run through. So, of course, I'm going to move the constant to the other side. Then I'm going to complete the square. I'm going to rewrite it, and then I'm going to solve it. Okay, so in the basics, those would be like the directions that I would be giving myself. So we'll start by subtracting 45. I'll get x squared plus 12x, leave some space, is equal to negative 45. I'm going to figure out what number completes the square. What completes the square for x squared plus 12x? 36. I'm going to add 36 to both sides. And that leaves me with an x plus 6 squared, and then negative 45 plus 36 is negative 9. I'm going to solve by taking the square root here. It's kind of always the same once I get to this point. So I'm going to square root both sides. And that will give me x plus 6 equals plus or minus. What do you guys know about the square root of 9 or negative 9? It's going to have an I in it, right? Where you know the square root of 9 is 3. If it's the square root of negative 9, you better put an I in your answer. There really isn't a real number. So we're going to say plus or minus 3i, and then subtract 6 from both sides. So minus 6 minus 6. And my final answer will be x equals negative 6 plus or minus 3i. I don't have to do any addition or subtraction there because they're not like terms. One's real and one's imaginary. So I'll leave them alone. I don't have any grumpy cat because that I couldn't have factored. I wouldn't have known that it was those two imaginary numbers. Questions? Okay, here is your assignment.